Hello everyone, today we are going to solve the problem pairs with certain difference. So we can see the question is given an array of integers ARR and a number k. We can pair two numbers of an array if the difference between them is strictly less than k. So our task is to find the maximum possible sum of such disjoint pairs. So each element of the array can use at most once only. So the sum of p pairs is the sum of all 2p elements of pairs. So like that. So if you see 3, 5, 10 is the first input and so on. And the second one is 5, 15, 10, 300. And we don't need to return any input or output or print anything. Just return the pairs. So they also give the expected time and space complexities. So let us take the second example for the logic explanation. So the second example is array is equals to 5, 15, 10, 300 and k, which is the difference, is equals to 12. So now let's see. So using these values, so we need to find the number of pairs. So our logic is going to be, so the first step, take a variable to count the number of pairs, or the program is to at last return the sum of the values of pairs in that distinct pairs, such that the k value difference will be less than in that pair. So let us take the sum value as sum is equals to 0 to return the output. So one step is simply over. So now another step is to get the least possible differences between any two elements. They should be very adjacent. So in another name, it is sorting the array. So by sorting the array, the similar kind of nearer values will be get adjacent. So just sort the array. So by sorting 5, 10, 15, 300 is the sorted array. So the third step is iterate the array from backward. So from the largest value to the smallest value. So for I is equals to, the n value is 1, 2, 3, 4. So for I is equals to 3, 2, 1. Because when we get to this pair, we need to check with this. So that is the reason. For I is equals to n minus 1 to greater than 0 only, not greater than or equal to 0. So when I is equals to 3, we will check if array of 3, which is array of 3 minus array of 3 minus 1, which is 2. So this value is 300 minus 15. Is it less than 12? So it is obviously not. So our updation step is I is equals to I minus, this is our updation step. So simply update I is equals to 2. So now array of 2 minus array of 1. So we can see 15 minus 10. Is it less than 12? So it is less than. So then we will be doing that. So it is actually 5. So simply add the 15 and also 10 to the sum. So 15 plus 10 is 25. So sum is equals to 0 plus 25, which is 25. and decrement I again. So I minus minus, because we also consider the I minus 1 value also. So we need to use the distinct pairs. So now I is equals to not 1, it is 0. So for I is equals to 0, you already see that the condition is exceeded. So we just break, or the loop is completed. So therefore the sum is 25, which is the output. So you can see the output is matching. So 25 is the output. So this is a simple logic we are going to use. So take a sum variable, sort the array, traverse from the backwards and check pairwise. So if the difference between the adjacent pairs is less than k, then add to the sum both elements and decrement. If not, just skip the ith value. So like that. So let's use the same logic. And sum is equals to 0. Now we need to sort the array. So sorting means ARR. So now for it I is equals to, they gave the n value, so n minus 1 to I greater than 0 and I plus plus. So in this case, if array of I minus array of I minus 1, if this value is, let us take the brackets, if this value is less than k, then sum plus equal to array of I and also array of I minus 1. So adding the two elements in the pair and decrementing I value. So sorry, again we need to decrement here. So at last return the sum value. So if you see the sample test case, there is a small error which is not equal to, it is minus. Again we can see, so we can see the k value is capital K, not small k. So we cannot distinguish with the first try. So we can see it is passed. Now the hidden test cases. So it is passed. Now the space of first line is 1, simple variable. The time of second variable is n log n, and for the third line also the time is n, and these are all big of 1 only. So at last, so time will be n log n, which is the highest possible time value in this code. Space is also highest, which is big of 1. So we can see our code is still more optimized in terms of space, because we expected of big of n, we use only big of 1 only. So no extra space. We just sorted the array and solved the program. So very simple. So kindly go and practice this program. The program link is given in the description. Thank you for watching. Subscribe for more videos.